Okay. So last time we have the half waves, huh? So the half wave. So what's the difference between half wave and full wave? What's the difference? Circuit difference between half wave. What's the first thing that you notice comparing half wave circuit and full wave? What's the difference?
I love the
With full waves, huh? So one thing is in half wave we are using only one diode. Sawa na last time. Hmm? Now in full wave we are using four diodes. Because that will be on the review questions. One of the review questions, huh? He will ask you how many diodes are you using. And that's why I'm telling you about this. Okay? So four diodes. The other one half wave is only. Actually, we have two types of full wave when circuit. We can do it in two types. Yeah, one is using four diodes. The other one is using two diodes only, but different input, different transformer. This is only a single phase, but that one is double phase. Okay, dual or something like three phase or so. It will have two sine wave input on the input side. So, but that's only using two diodes. There's a kid. It's a kid, no? Watching. You wanna study here. Okay? Huh? So that's how I think that would be the fourth lab. We will have full wave. This one is what we call full wave by bridge circuit. We call it full wave rectifier bridge circuit because you know why? This looks like a bridge. Oh. You know a bridge? Yeah. That's why I call it full wave rectifier bridge circuit. Okay. Now, how it works? This is the thing, right? This is the question. So again, we have an input of sine wave there, like last time. The tables for lab 2 and lab 3 is identical. It's almost same, exactly the same. So meaning the same process that you will do like last time we did. Okay? The only thing, the difference is only the circuit. And of course, the waveform. Output. The output will be different. Now, okay, half wave, we just rectified the half. That's why it's called half wave. Half of the waveform, half of the inputs, But now, this thing will rectify both cycle. Positive and negative cycle will be rectified and produce it on the output. How? So, during half cycle, one half cycle, positive, right? So, the thing is, what will happen here? What will happen? The thing is, you have to identify which diode will be forward bias. That's how you do it. Have you discussed this one in the theory? Not yet. Not yet? Oh. So here, you only identify which diode will be forward bias. Means forward bias means turned on. Right? Reverse bias is off. Correct? So, where? Where do you think? Which diode will turn on? So, during positive cycle, half cycle, which diode now turns on? Or which diodes with S? Okay? So, what do you think? Anyone? 1 and 2. This will turn on. Is that correct? Any other idea? Any other? So we are on the plus, okay? On the top, minus here, negative side here, plus side here. So plus side. So meaning I will draw the flow, right? Plus, plus is flowing there. So meaning when it comes here, this will turn on, or this one?
This is D1.
D1, this one will turn on, right? Because positive anode, going here, So going there, going to the load. Go to the load. Correct? And on the negative terminal, which diode now turns on?
Two.
2? Let's see. The negative goes here, goes there. 2 will turn on.
Yes.
Why?
No.
Which turn on?
Three.
3. This turn on. Goes there. See?
Yes.
Huh? Therefore, which diode turn on? Which diodes turn on? Diode 1,
And three.
3. Forward bias. FB.
Oh, three. Oh.
La la la. For negative. Negative here. Mo yun na. Here. Negative. Cathode. It will not come here. It will not enter. He cannot enter here because it's positive. He cannot enter. He's a negative. So, he cannot enter there. He is supposed to be, he will enter here, this side. That's why, plus minus here. So, therefore, he will get an output. So, P output. Because the positive polarity and negative polarity goes on the load. So there's an output. Correct? Is that right? Okay. And then next, the next one. The next one, what? Which diode now turns on? Again. So, the next cycle would be, kita. So, that's the next cycle. Alright? So, negative now. Let's try to, where it will enter? Where it will enter? D4, huh? It will enter D4. It will enter here? No. Because this is positive, right? That negative will go here, go there, and so agree? And therefore also that positive now here is positive now. Where it go? Huh? D2, D2, it will go there. Same thing. It will reach the load. Clear? Is that good? Okay. So therefore, also, the output reaches, or the input reaches the output. Huh? Agree? So again, it will give you an output signal.
Should be minus one.
Which one?
The second one.
This one. Up.
Why?
It's positive. Because it's still here. Oh. The positive goes there. Oh. Same thing here. Positive goes there. Oh. When you measure it, positive, negative, huh? So both will be positive side. Okay? Same as this and same as that. So you spec, alright, you should spec waveform like this one in your output signal for the oscilloscope. Okay? And again, you have to measure also here on the negative half cycle, D2 and D4, so forward bias. Okay? Alright? And also again, don't forget the formula for ripple factor. Is that right? There's a ripple factor formula there. Ripple factor, which is V out AC.
Yes.
Is that AC?
Yeah.
V out DC. Okay? And you can write this one on the report, on your reports, right? You can write this one, solution. Because there's a part of, in the report, there's a part of calculations, huh? You can put this solution on in that part. Okay? And also, you can also add, remember I told you last time the DMM. When you are using DMM, what you are measuring in the DMM is what? In RMS values, huh? But it's not showing in the book. It's not showing here in the books, huh? You will be wondering why the waveform, the value of the waveform voltage is different from the value that you are measured using DMs, huh? It's different. The measured value with the waveform, using waveform, is bigger compared to the DMM value when you're using DMM. Because there, we know that in DMM, digital multimeter, we are measuring BRMS values, huh? And the formula should be what? What's the formula again? Using RMS? 1 over 2 square root of 2, B peak to peak. Because here we will use peak to peak, because we are using peak to peak because we measure peak to peak values in the table that you have, right? So again, peak to peak values are measured, okay, from this point until that point. That's peak to peak, So these are peak to peak values. This one are peak to peak values, while this one is what we call peak only. Okay, peak to peak values. See, that's why when you calculate the VRMS using V peak to peak values, the VRMS value is the one that you measure DMM, the first one, the first column on the table. Okay, 10 volts. Now we will use 10 volts. This is the VRMS. Actually, this is the VRMS value. 10 volts. We will use 10 volts. Last time I gave you 6. Last time 7. Now you can use both 10 volts. Okay? You can use both 10 volts. Class? Any clear? Wala. Any question? No? Honey, question? It's okay? Sure? No? Good? Where's the map? Marwan? Marwan? Nasaan? What's his name? Ahmad. Ahmad, huh? Khalid. Khalid? Okay. So I remember already your names. Okay? So, let's go there.